Welcome to Chapter 9, and this is Section 1. We're going to look at factoring by GCF. Go ahead and put today's date in the top right-hand corner. And our target for today is that I can factor a polynomial by its GCF. So first things are the factors, and factors are the numbers or variables that you multiply together to make another number. So that you multiply together to make another number. An example of this would be like if I were to ask you for the factors of 8. Well, we know 1 and 8 multiply together to make 8. And after 1 we know 2 and 4 multiply together to make 8. So the factors of 8 would be 1, 2, 4, 8, because they're the numbers that can be multiplied together to make another. Now factoring is when we factor a polynomial, we find its completely factored form. So that means we find all the factors that go into it and break it back down. For our purposes today, factoring is going to be the reverse of distributing. So distributing means we multiply together. Factoring means we're going to do the reversal and we're going to break it back apart. So factoring using the distributive property, which is also known by factoring by GCF, is for any number of terms. That means I could have 5 terms, I could have 7 terms, I could have 2 terms. So it's for any number. And just a reminder, I know we've heard the letters GCF before, but GCF is the greatest common factor. It's the largest number and variable, or variables, there could be more than one, that can go into all terms of a polynomial evenly. Now, the very first thing you're going to try if we're looking for the largest number that can go to all of them evenly is try the smallest one that you can see. Try it first and then try its factors. Alright, and then we're going to take out the variable that is in all the terms with the smallest exponent. We'll see why here in a second. Now lastly, our steps for GCF. Step 1, identify the GCF among all the terms. So look at all the terms there in the polynomial, find its GCF. 2, divide all the terms by the GCF. And lastly, your answer is written like this right here. You have your GCF on the outside of your parentheses. Then inside you have the quotient of the polynomial, because up here in step 2 where we divide, quotient just means it's the answer to the division. So now let's apply these steps into an example. So we factor by this distributive property. That's also mean factoring by GCF. So step 1, find the GCF among our terms. So I have 12 and 16. So we always try, can 12 go into 16 evenly? No, it can't. So I'm going to show some scratch work over here. I'm going to try 12. And say, we already tried 12, it didn't work, so 12 can be broken apart into 3 and 4. And remember, because it's the greatest common factor, we always want to start with the bigger one. So we'll start with 4 and say 4 is a factor of 12, so that works. And then can 16 be divided by 4? Yeah, 4 times. So GCF then is going to be 4. Then we look for any variables they have in common. They both have a's. We want to take out the a with the lower power, because remember this means it has 2 a's. This one means it has 1, so they have 1 a in common. So just a to the first. So I have my GCF. Now step 2 in factoring says to divide all the terms in the polynomial by the GCF. So we're going to divide everybody here by 4a. Then we're going to write our answer. We're going to put our GCF on the outside, so 4a. And then when we divide, we put it in the middle of our parentheses. So 12 divided by 4 is 3. A squared divided by a, it gives us a to the first. And plus 16 divided by 4 is 4. And a divided by a cancels. And that's our answer. Now we can check our answer to make sure we did it correctly. And because this is the reverse of the distributive property, if I'm going to check it, all I have to do is distribute and say 4 times 3a is 12a squared. 4a times 4 is 16a. And is this our original problem? Yep. So we check. We got our... Oh, there we go. So, step 1 is to find the GCF of all 3 terms. So we always want to try our smaller number first. So we tried 9. And can 9 go into 18 evenly? Yes, it can. It can go into it 2 times. We say, can 9 go into 12 evenly? No, it can't. So I have to take 9 and break it apart. We already tried 9 and he didn't work. So 9 breaks apart into 3 and 3. So then we try 3. Can 18 be divided by 3 evenly? Yeah, it gives us 6. Can 12 be divided by 3 evenly? Yep, it gives us 4. So our GCF this time is 3. Then we check it for variables. So they all have C's. And I want to take out the C with the lowest power because that means that's the most I have of it in that one term. So our lowest power is C squared. So take out 3c squared. And then D, I have D squared, D to the first, and then D to the third. So once you want to take out the lowest power, so that's D. So our next step is to divide everybody here by their GCF of 3c squared, D. So when we write out our answer, our GCF goes on the outside. And then we divide, we put our answer inside the parentheses. So we just divide each term at a time. So 18 divided by 3 is 6. And then remember, we subtract our exponents when we're dividing. So 3 minus 2 gives us c to the first. D squared minus d to the first gives us d to the first. Plus 12 divided by 3 is 4. And then c squared divided by c squared cancels. And d divided by d cancels. And plus 9 divided by 3 is 3. C to the fourth over c squared gives us 4 minus 2 is 2. And then 3 minus the 1 hidden here is 2. So 6cd plus 4 plus 3c squared d squared is inside our parenthesis. And our GCF is 3c squared d is on the outside. And that finishes up for factoring by GCF. So factoring by grouping is for 4 terms. Last time we factored by GCF, which was for any number. But grouping is specifically for 4 terms. So step 1 is to check all 4 terms for GCF first. If there is one, factor it out first. So no matter what type of factoring we do, our first step is always going to be to check for GCF. It's always going to be the very first thing we do in all of our factoring. Step 2 says to check the first 2 terms for a GCF and the second 2 terms for a GCF. If they have a GCF, then we're going to group them. So if they have a GCF, group them. That's where our term grouping comes in. Factoring by grouping. We group the first 2, and we group the second 2. However, if they do not have a GCF, we're going to have to change the order to make two groups of two terms with a GCF. So if for some reason they do not have a GCF, we're going to have to change their order. That's the commutative property that lets us change the order of our terms. Step 3, factor the GCF out of each group. That means there should be 2. We'll have 2 GCFs. And then lastly, if we have factored correctly, the terms in each parenthesis should be the same, should be identical. So if we have factored correctly, we'll have the parentheses being identical. And lastly, we write our answer with our GCFs in our first parenthesis. And then in a second parenthesis, we have the one that's the same. So in GCF, we only had one parenthesis. In grouping, our answer has 2. It'd be 2 binomials. So answer will be 2 binomials. So let's put these steps to work. Let's see an example. Example 1 gives us 4ab plus 8b plus 3a plus 6. So step 1 is to check all 4 terms for a GCF. So we always look for the lowest number, so that's 3. We say, can 3 go into 4 evenly? No. 3's prime, so he can't break apart anymore. So there isn't a GCF among numbers, so we look at the variable. He has an A, but these 2 don't. So we can't take out an A. First 2 have B, but the last 2 don't. So there aren't any coefficients, there aren't any variables to take out. So no GCF of all 4 of them. So step 2 says to group the first 2 terms and the second 2 terms and check for a GCF of them. So I'm going to pull up a blind because the very first thing we need to do is just look in that first parenthesis. Focus on this guy by himself. 4ab plus 8b. Does it have an individual GCF? It does, because our smaller number is 4, and 4 can go into 8 evenly, so I can take out a 4. And they both have b's. So the first one has a GCF of 4b. So then we focus on just our second parenthesis. We check him for a GCF. So we start with 3, and 3 can go into 6 evenly, so I can take out a 3. He has an A, but the 6 doesn't, so the only thing I can take out here is just the GCF of 3. Now once we check the groups for GCF, we factor them out. So this brings in our factoring by GCF, where we divide everybody in the first parenthesis by its GCF of 4b. And we divide everybody in the second parenthesis by its GCF of 3. Now this is 2 sets of GCF, so I'm going to write my blank for my GCF to go, and then my parentheses, then another blank for the GCF to go, and another parentheses. So GCF, my first parentheses, 4b, so it goes on the outside, and then we divide. 4 divided by 4 is 1. I don't have to show it. A doesn't have anybody to go with, so it drops down, and b divided by b cancels. Now drop down my plus sign. 8 divided by 4 is 2, and b divided by b cancels. Now here's where your signs have to come into play. If he's a positive 3, then I need to drop down plus 3 as my GCF, because plus 3 means he's positive 3. And now we divide our second parenthesis. So 3 divided by 3 is 1. I don't have to show it, but I can drop down my A. Plus 6 divided by 3 is 2. Now, step 3 said if we did it correctly, our parentheses should be the same. 4a plus 2 and 4a plus 2. Oh, sorry, just a plus 2 and a plus 2. Since they are the same, that means I can go ahead and write my answer. So we get 2 parentheses for binomials. Our first GCF goes in our first parenthesis, so 4b. And our second GCF goes in our first parenthesis, so plus 3. Then our second parenthesis, the one that's the same, so a plus 2. And that's our answer. So what we can do now is we can check this. As GCF was the reversal of the distributive property, so we distribute to check it. This is the reversal of foiling. So we FOIL and say 4b times a, put on my alphabetical order, so it's 4ab. 4b times 2 is 8b. Then we do our inside. 3 times a is 3a. And 3 times 2 is 6. And we look, is this the same thing as our original problem? Yep, so we check. Now let's see example 2. We have 35x minus 5xy plus 3y minus 21. So first step is to check all 4 terms for GCF. So our smallest number is 3. We say, can 3 go into 5 evenly? No, it can't. So then we check, do they all have the same variables? No, they don't. So where we have 4 terms, that means it's a grouping. So that means I want to group the first 2 terms and group the second 2 terms. And look for GCF in the first parenthesis. So our smallest number is 5. And we say 5 can go into 35 evenly. So GCF is 5. And they both have x's, so I can take out an x. Now GCF is 3. Because 3 is our smallest number. And 3 can go into 21 evenly. They don't both have y's, so it can't take out a y. So now everybody in the first parenthesis gets divided by its GCF of 5x. Everybody in the second parenthesis gets divided by 3. And our next step has the GCF on the outside in our parenthesis. GCF on the outside in our parenthesis. So GCF goes on the outside, 5x. Now we divide. 35 divided by 5 is 7. X divided by x cancels. Negative 5 divided by 5 is a negative 1. Don't have to show it. X divided by x cancels and leaves me with y. Now, GCF is a positive 3, so plus 3. And 3 divided by 3 gives us 1. We don't have to show it, so we drop down our y. And negative 21 divided by 3 is negative 7. Now we check to make sure our parentheses are the same. So I have 7 minus y and y minus 7. Well, they're almost the same. Their order's wrong. We need y in front on this one, so we need to change their order. But also, this 7's positive and this 7's negative. Oh, sorry, being a little crazy there. And then this y's negative and this y's positive. So where their signs are different, that means up here when I take out my GCF, I need to take out a negative. It doesn't matter if you take it out in the first or the second one. I have to take it out in the first one, a negative 5. So then 35 divided by negative 5 is negative 7. And then negative 5 divided by negative 5 is a positive 1. So now my signs are where they need to be. I have a negative 7 and a negative 7 and a positive y and a positive y. Now let's just rewrite this step to where the parentheses are in the right order. So I'm just going to flip my positive y and my negative 7. So drop down my negative 5x and say y is now in front, so y in our negative 7. And then just drop down this whole part as is. So plus, let's try that again, plus 3 times y minus 7. Now we double check. Our parentheses are the same, y minus 7 and y minus 7. So now we write our answer. We get 2 parentheses big enough for binomials, so 2 binomials. And our GCF goes in the first one, so negative 5x plus 3. And then we drop down our parentheses, that's the same, y minus 7. And that's our answer. Let's see one more example. Example 3 has 2my plus 7x plus 7m plus 2xy. So step 1, check all 4 terms for GCF. Our smallest number is 2, and 2 cannot go into 7 evenly, and they do not have any variables in common. So where it has 4 terms, we group the first 2, we group the second 2. We check the first one for GCF, and we try 2. Can 2 go into 7 evenly? No, it can't. And do they both have m's? No. Do they both have y's? No. They don't both have x's. So they have no GCF in the first parenthesis. So let's check our second one. So our second parenthesis has another 2. So 2, we already said it cannot go into 7 evenly, so no GCF. Then we check them for variables. Do they both have x's? No. Y's, m's? Nope, no variables in common. So our first nor second group had a GCF, and the whole thing doesn't have a GCF. So this is where in our notes we said if it doesn't have a GCF, we have to change the order. We have to use a commutative property to create a group with a GCF. So let's start off with our 2m y. So if I have a 2m y, is there anybody else up here that you think could find a GCF with 2m y? How about our 2xy? They both have 2's, they both have x's, they should have a GCF. Our next one's 7x and 7m. They both have 7's, so we can tell automatically they're going to have a GCF. So now we group the first 2, we group the second 2, and try to find the GCF again. So GCF is the first one, they both have 2's, so I can take out a 2, and 2 can go into 2 evenly. They both have y's, so I can take out a y. Now we find our GCF of our second one. They both have 7's, and 7 can go into 7 evenly, but they don't have any variables in common. Now the whole first parenthesis is going to get divided by its GCF of 2y. And then we put our GCF on the outside and we make our parentheses. There we go. So now we divide. 2 divided by 2 is 1. I don't have to show it. M drops down. He has a mate to go with. Y divided by y cancels. Plus 2 divided by 2 is 1. I don't have to show it. I drop down my x and my y's cancel. Now it's positive 7, so plus 7. 7 divided by 7 is 1. I don't have to show it, so I drop down my x. Plus 7 divided by 7 is 1. Don't have to show it, so I drop down my m. So once again, we're to the step where we check our parentheses, make sure they're the same. And our first parenthesis has positive m plus x, and our second parenthesis has a positive x plus m. Good thing is this time their signs are the same. Bad news is that they're out of order again. So this doesn't need to be m plus x, it needs to be x plus m. So we'll just change around. So 2y times x plus m. And we'll drop down this whole second part as is. So plus 7 times x plus m. So now we check. Our parentheses are the same. So I can write my answer. 2 binomials, and my first binomial is made up of the GCF, so 2y. Our other GCF is plus 7. And then the parentheses, that's the same, x plus m. That's our answer. And that finishes us up. Thank you.